will see the reaction with nitrous acid. Now nitrous acid, you know, it is not stable in nature, nitrous acid. So it is being prepared in situ. Situ means immediately prepared and used. Nitrous acid is prepared. So what will I do? I will take NaNO2 plus HCl. So what will I get? I will get HNO2. This is your nitrous acid plus NaCl. HNO2 plus NaCl. This is your nitrous acid. I got it. Clear? Now, what will I do is now we will take amines. That is primary amines RNH2 plus HONO. Remember that what I said? 1 degree amine, primary amine. Alright? I have taken it. Now HNO2 I have written in this particular way. HONO. Clear? Now, in presence of 273 to 278 Kelvin. 273, that is ice cold solution, we can say 0 to 5 degrees centigrade, isn't it? 273 to 278 Kelvin. What I am going to get it? I am going to get it nothing but, that is here also I will be taking, that is RNH2, and here also I will be taking, that is nothing but HCl. I will be taking it. Alright, HCl I will be taking it. Nitrous acid, and here also HCl is required. HCl. So what will I get? Rn triple bond N plus Cl minus. Rn triple bond N plus Cl minus. So you get a diazonium salt. You get a diazonium salt. Alright. Rn, then triple bond, that is N. Here it is. Then Cl minus. So what you get it is that here H2 and this oxygen. Clear? So it forms what? H2O. Now this hydrogen and this oxygen, again it forms water. Alright, what I said? See, Rn triple bond N, then Cl minus. So hence what is going to form? Here nothing but H2 reacts with oxygen, or you can say H2 can react with this oxygen also. It can react with this oxygen and it forms water. This HO reacts with OH. Alright, this HO reacts with this H to form what? Again another water. 2 molecules of water is released, and hence you get a diazonium compound, you get it. Clear? Now this diazonium salt which is being formed, the process is called as diazotization. The condition which I have given to get the diazonium salt, it is known as diazotization. Diazotization, we can say that, diazotization. Now this further reacts with water. The water which is released, it reacts further with it, and it is going to form ROH plus nitrogen plus HCl. ROH plus nitrogen plus HCl, we can say that. ROH reacts with plus nitrogen plus HCl. Actually the cleavage takes place here. When the cleavage takes place here, alright, this first is released, N2 we are getting it, nitrogen. Clear? Then after that this R plus reacts with OH minus to form what? ROH, and H plus goes with Cl minus to form what? HCl. Clear? So let me tell you, this particular reaction is a test for primary amines, because no other amines gives nitrogen when it reacts with nitrous acid. You can note it down. No other amines, that is secondary and tertiary amines or quaternary amines, does not give nitrogen on reacting with, what you can say, that is nitrous acid. Reacting nitrous acid, we can say that. No other amines. Only primary amines give this particular reaction, so to say. Nitrogen is not released. But in here, if you take here aniline, if instead of R, if you take here aniline, C6H5NH2, you will be getting here C6H5OH finally, plus nitrogen plus HCl. That is phenol, you will be getting it. So this reaction is used for the conversion of phenol. We have done it already in the phenol chapter. Alright. If I take here C6H5NH2, that is aniline, you will be getting here C6H5OH plus nitrogen plus HCl. So with aniline, it is being possible. Means with aromatic amines it is possible, and with primary amines it is possible. It is not possible with secondary, tertiary and quaternary amines, so to say. Now secondary amines, what it will do? Secondary amines, rather what it will do? It will not produce nitrogen gas. Then what it will do? See here, secondary, that is amines R, N, R and H plus HONO, that is nitrous acid. HONO from where you will get? This is the main reaction. This particular is the main reaction. Clear? Always you will do this particular reaction. Then only you will be getting nitrous acid. First you have to do this reaction, then you will be getting nitrous acid. So hence what I am going to get it? That is nothing but R, N, that is R, it's already there. Alright, then HOH is removed from here, you can see that. Then here it will be what? N double bond N then that is N single bond N, then double bond O. Alright, N single bond N, double bond O. So nitrogen is having 3 bonds. This nitrogen 3 bond, this nitrogen is also having 3 bond. We can say that. Clear? Now, this particular one which you got it, this is called as yellow oil. This one is known as yellow oil. For example, suppose if I take here C2H5, both R as C2H5, if I take R as C2H5, let us say, if I take R as C2H5, so you will be getting C2H5, N, C2H5, N single double bond O. That is yellow oil. So N nitroso, N ethyl, that is amine, we can say that. Clear? So N nitroso, N ethyl amine, that is a yellow oil. I am getting it. That's a yellow oil. This is known as yellow oil because the color is yellow in nature. We can say that. So what I said, if I take ethyl group here, so it is N nitroso, N ethyl, ethanamine. Alright, again I repeat, N nitroso, N ethyl, ethanamine. We can say that, which is known as yellow oil. Fine. Now this yellow oil gives you further reaction that you have to note it down. This is an observations. Yellow oil reacts with that is your phenol in presence of sulfuric acid. Means acidified phenol, we can say that. Phenol in presence of sulfuric acid to give you a green solution. Which further reacts with NaOH, will add NaOH to it to give you deep blue solution. Which further on dilution gives you a red colored solution, we can say that. What I said, this yellow oil which you will be getting it, which is yellow colored, you add phenol along with sulfuric acid. You add phenol along with sulfuric acid. You will be getting a green colored solution, a green solution, we can say that. Now you add NaOH to it. You will be getting a blue color solution, a deep blue color solution. Then you add little bit of water to it. You go for dilution. You will be getting a red colored solution. Now this reaction is called as Lieberman's nitroso reaction, which is given by secondary amines, not by any other amines, we can say that. Lieberman's nitroso reaction, Liebermann''S. Lieberman's nitroso reaction, which is given only by secondary amines, not by any other amines, we can say that. Clear? So this is how the reaction is being carried out. Got it? So primary amines goes diazotization reaction, we can say that nitrogen gas is released. In secondary amines you get yellow oil and you get this particular observation. And now with tertiary amines we will see what is going to happen. With tertiary amines, let us see what is going to happen. Now with tertiary amines, that is nothing but R3N plus HONO, that is nitrous acid. Again I repeat, that is HONO from where I am going to get it? I am going to get from NaNO2 and HCl, which will give you HNO2 plus NaCl. So here what I am going to get it is that R3NH plus then NO2 minus. See, R3NH plus, then what is that? NO2 minus. That is, you will be getting this particular one. Which upon heating, when you will be heating this particular one, when you will be heating this particular one, what I am going to get is that this is nothing but I am going to get it alcohol first. A smell of alcohol is being given out. A smell of alcohol, you know, it's a burning smell we are getting it. That smell of alcohol will be given out, and whatever the product is left. So what is being left? Yellow oil is left. That is RNR single bond N double bond O. We can say that. Because two alkyl group, we can see RNR single bond N, then another that is, we can say that R3NH plus, another N and double bond O. So in this way you get, and that is nothing but yellow oil, will be getting it. So this particular reaction, got it, is nothing but the reaction given by tertiary amine, so to say. Alright, it is given by tertiary amine, so to say. But let me say you, they here the one which you are getting it, this will not react with NaOH and this further to give you a particular solution, because it is quite less reactive in nature compared to the one which we get it from secondary amine, so to say, we can say that. It will give you the color, you will be getting it, but the color will be not so bright. As I said, you know, deep blue solution, deep red solution, you will not be getting deep blue, but pale blue you will be getting it. So hence you find it with secondary amines, as I said you, this Lieberman's nitroso reaction is quite prominent. Alright, it's quite prominent. Listen carefully the words which I am speaking to you. With Lieberman's nitroso reaction which is taking place with secondary amines, it is quite prominent compared to what you will be getting with tertiary amines, so to say. Now next is your carbylamine reaction. Another reaction which is given only by primary amines and aniline, we can say that, which is given by primary amines and aniline, not with secondary or tertiary amines. You will be getting this particular reactions. Clear? That is carbylamine reaction, and isocyanide will be found, which is a highly poisonous gas. A highly poisonous gas, we can say that. That is RNH2. Again, it is a primary amine. This is a tertiary amine. Over. This is primary amine. Will react with what is, you can say, KOH, alcoholic, and CHCl3, chloroform. Got it? CHCl3 chloroform. Upon heating, what you will be getting? You will be getting RNC, that is isocyanide, plus KCl plus water. You will be getting RNC plus KCl plus water. So here it is 3 KOH because 3 Cl is there and 3 water, you will be getting it. This is isocyanide, we got it. Isocyanide, it can be methyl isocyanide if R is methyl, if R is ethyl, it is ethyl isocyanide, or if R is an what you can say, benzene ring, like if I use here aniline, so 6H5NH2, then you will be getting phenyl isocyanide, you will be getting it, or phenyl carbylamine, also we can say that, because NC, otherwise also called as carbylamine, which is a highly poisonous gas, this particular is. Got it? Highly poisonous gas, and it's not allowed to do it in the lab because it may cause severe accident, because this gas is readily absorbed by the skin, we can say that. Highly poisonous gas. So this is given only by primary amines, not by any other amine, so to say. Next is, we'll see the reaction with CS2, carbon disulfide. The reaction with CS2, carbon disulfide, you will see the reaction. See here. So RNH2, when it reacts with CS2, we can say that, when it reacts with CS2, RNH2. So what I am going to get? I am going to get first a secondary product, that is RNH, then it is C, that is RNH, yes, it will be CS, got it? And nitrogen is having 3 bond and another bond with SH, correct? So it is RNH, then you will be getting SH and C double bond S, we can say that. So this is dithiocarbamic acid, we can say that. Dithiocarbamic acid, so to say, we can say. Now, which further reacts with mercury chloride, HgCl2, mercuric chloride, which further reacts with mercury chloride to form what? Rn double bond C double bond S, we can say that. Rn double bond C double bond S plus HgS, got it? Plus HgS plus HCl, we can say that, 2HCl, we can say. Clear? So in this way the product you will be getting it. Now this is called an alkyl isothiocyanate. Alkyl isothiocyanate, we can say that, alkyl isothiocyanate. Now this isothiocyanate formed in this reaction possesses a pungent mustard oil like odor. This which has been formed, alkyl isothiocyanate, it possesses a pungent mustard oil like odor, and hence this particular reaction is called as Hoffman's mustard oil reaction. For this reason, this reaction is called as Hoffman's mustard oil reaction, and it is used for the test for primary amines. Again, this particular reaction is used for the test of primary amines, so to say. Hoffman's mustard oil reaction, so to say, it is used for the test of primary amines. Clear? Now, next is, if you do the same reaction with what you can say, with secondary amines, what will happen? Let us do it and see. Secondary amines. Let us say I am here R and this. Here I am going to get it this. Now here no further reaction is going to take place with secondary amines. No further reaction I am going to get it with secondary amines. Why? Because it does not possess any alpha hydrogen atom. Initially there was hydrogen. So due to the presence of alpha hydrogen atom, the reaction was taking place. But here, due to the absence of this particular hydrogen, no reaction is going to take place. The answer is no reaction. We can say that. With secondary amines, no reaction. With tertiary amines also same thing. If I do the reaction tertiary amines, suppose I'll take it here R. Alright. So this reaction is not going to take place at all. No reaction is going to take place. Tertiary amines, no reaction is taking place from the beginning itself due to the absence of the hydrogen atom. Alright, due to the absence of the replaceable hydrogen atom, that is alpha hydrogen atom. Alright, here that is hydrogen was there, here nothing is there, here hydrogen was there, here nothing is there, so no reaction is going to take place. With tertiary amines, from the beginning itself no reaction, at least in secondary amines one step it takes place. Then with mercury chloride no reaction because of the absence of the alpha hydrogen atom. But with tertiary amine from the beginning itself, I will write it here, no reaction from the beginning itself, because there is no replaceable hydrogen atom. No replaceable hydrogen atom is there. So there is no reaction with tertiary amines, we can say that, with carbon disulfide. So hence you can see that we are getting Hofmann's mustard oil reaction only with primary amines, so to say, we can say that. Clear? Now if you do the same reaction with aniline, we can say that. If you do the same reaction with aniline, then what is the product you will be getting? Let us see. Let us see what is the product I am going to get it if I do the same reaction with aniline, so to say. So here that is benzene ring NH2. Here another one, that is benzene ring NH2, we can say that, plus what I said, I will be using CH2. So here SC double bond S, and I will be heating it. What will happen is, see, H2S will be produced instead of water. Suppose oxygen would have been there, water would have been produced. So here H2S will be produced. Alright, that is minus H2S. And what is the product? The product is the remaining product. What is being left? That is your remaining product. That is NH. Then it is C. Here also same thing. NHC double bond S. Finished. The remaining product. Now this reacts with conc HCl. Alright. This one I'll react with conc HCl. On reacting with conc HCl, what I am going to get it? That is nothing but NC double bond. That is this product I will be getting it. N double bond C double bond S. NC double bond S. And the remaining is a product with HCl. So and the remaining is here nothing but benzene ring. What is being left? NH, and here that is H, and here HCl. So it will be NH2 dot HCl. You will be getting it. Alright, NH2 dot HCl. So aniline hydrochloride. NH2 aniline hydrochloride. And this particular one is known as phenyl isothiocyanate. That was alkyl isothiocyanate. It is phenyl group is here. So phenyl isothiocyanate, we can say that. Clear? So in this way, the reactions you will be getting it with, that is aniline. Now, next we will see the reaction with Grignard reagent. What it happens? The reaction with Grignard reagent, what it happens? Now, RNH2 plus R dash MgX. We can say that. Grignard reagent on reacting with ether. That is dry ether, rather I should say dry ether, that's an inert solvent. So what I am going to get it, I will be getting it is nothing but RH. One compound I will be getting it, that is R dash H. Clear? Plus Mg, one bond with X, one bond with X already, this R dash H, and here it will be getting it nothing but NHR. One H reacts with R dash to form alkane. This is your alkane. And Mg, one bond with X already is there, another bond will be with NHR. Say I have written it. Clear? So in this way you got the product. Clear? So whatever it is, whenever that is amines reacts with Grignard reagent, you get what? Alkanes. Alright, you get alkanes. It's a substitution reaction you will be getting, that is alkanes, correspondingly you will be getting it. Fine. Now next is primary amines upon oxidation with acidified KMnO4. It gives aldimines. Got it? Primary amines upon oxidation with acidified KMnO4. Now primary amines means, let us say C2H5NH2. Let us say in presence of that is alkaline KMnO4, I said oxidation. So here it is C2H5NH2. As you can see it here, amines when it is getting oxidized in presence of this alkaline KMnO4 which acts as an oxidizing agent. What will I get? I will be getting CH3 CH double bond NH. Because if you don't understand, I will break it up this one, CH3 CH2. So here, what is that? CH3, CH, double bond NH. One H from here, another H from here, and oxygen releases, that is water molecules. And here, the one which I get it is imines. This one is double bond NH is imines. So we get it an aldimine, which further reacts with water, to give you what? Nothing but CH3, CHO. This double bond NH is replaced by O, and hence we get ammonia gas. Finished. In this way we can prepare aldehyde. Similarly, if you are taking here, that is secondary amines. If you are taking here, that is, so to say, that is secondary amines I am saying, that is isopropylamine. I am very sorry, isopropylamine if I am taking it here. Alright, that is nothing but here another CH3. Alright, so here it will be, that is CH3. Clear? And double bond NH. So here what it will be? It will be nothing but C double bond O and here CH3. What is that? Acetone. I will be getting it. Clear? If I take isopropylamine, this is your isopropylamine, so to say. Isopropyl. Same primary amines. Isopropylamines will give you acetone. Alright. Now secondary amines, if I take it, what is going to happen? Secondary amines. C2H5N, that is C2H5H. Alright. Plus nascent oxygen, which you will be getting it from alkaline KMnO4. Alkaline KMnO4, we can say that, which acts as an oxidizing agent. So hence you will be getting it here C2H5N, another C2H5, here N, then C2H5, and here C2H5. So here it will be two molecules, you will be using it here. Alright, and water will be released, plus water you will be getting it. Plus water you will be getting it. Further. Now this this, what you can say, secondary amines, you got this particular product. With tertiary amines, with great difficulty the reaction is taking place with the absence of this hydrogen atom. With great difficulty the reaction takes place. In presence of hydrogen peroxide, it forms triethyl, that is amine N oxide. Alright? With great difficulty the reaction is taking place. You have to note this point. With great difficulty, with hydrogen peroxide only, or with any peroxide only, the reaction is taking place with tertiary amines. And what is going to form? If you are taking ethyl here, alright, ethyl, that is tertiary amine containing the ethyl group. So you will be getting triethyl amine N oxide, you will be getting it. Trimethyl amine N oxide, we can say that. Now, this is triethylamine N oxide or trialkyl amine N oxide. Any alkyl group you can use it. But again I repeat, it takes place with great difficulty. It is not so easy, we can say that, due to the absence of replaceable hydrogen atom. Fine. Now next is aryl amines are oxidized slowly. Aryl amines, aniline. We are talking now about aliphatic amines, alkyl amines. But aryl amines, they oxidize slowly even by atmospheric air and become dark in color on standing. In the beginning itself we have studied in the properties. Got it? That aryl amines on standing, it becomes brown in color, we can say that. So it becomes a dark aryl amine. So in this way, aryl amines, you can note it down. When you are oxidizing with bleaching powder as an oxidizing agent, bleaching powder CaOCl2, CaOCl2, if you are using bleaching powder as an oxidizing agent, then it will gives you a violet colored compound. Again I repeat, aryl amines are oxidized slowly, we can say that, by atmospheric air, we can say aryl amines, and becomes a dark in color on long standing. On standing for long time, on exposing it in air for long time, it becomes dark in color. So on that basis only I am saying you that if you use aniline and if you use bleaching powder as an oxidizing agent, then you will be getting a violet colored compound. If you use conc, that is H2SO4 along with K2Cr2O7, that is acidified K2Cr2O7, but with conc H2SO4 you need to acidify it, then you will be getting intense blue colored compound. Intense blue, not dark blue colored compound, you will be getting it. Aniline will turn to. Now if you are using, that is acidified K2Cr2O7 with dilute H2SO4 along with copper sulfate. Note it on all these things. Aniline reacts with acidified K2Cr2O7. Acidified, how you are doing acidified? By dilute H2SO4 along with copper sulfate. Then what you will be getting? You will be getting aniline black dye. It will become black in color, which is called as aniline black dye. You will be getting it. Got it? Clear? Otherwise, we can say that aniline reacts with K2Cr2O7 under controlled oxidation. Means simply if you keep it in air, got it? Or if you add little bit of dilute K2Cr2O7, not copper sulfate, only dilute K2Cr2, dilute H2SO4 in K2Cr2O7, you will be adding it. Means acidified K2Cr2O7 when reacts with aniline, or listen carefully, aniline is left open in the air, then this reaction will be slow. Alright, but if you add little bit of dilute K2Cr2O7 along with H2SO4, dilute H2SO4 along with K2Cr2O7, then you will be getting parabenzoquinone. Parabenzoquinone. This one. This is aniline under slow oxidation.